exaggerate. All right. So, yesterday we talked, no, not yesterday. Let me back that train up. Monday, we talked about adding and subtracting matrices. Okay? So, if I had a 2 by 3 matrix, 2 by 3. What size matrix could I add that to? Or add to that? A 2 by 3. Okay? Remember, in order to add, they have to be the same exact dimension. And my answer then was a 2 by 3. Okay? Multiplication is a little bit different. Okay? So if you take a look at this one, it says, Reuben stops at a convenience store. Okay? He's going to a convenience store. On his way to school to buy snacks. He buys 4 bags of chips. They're 30 cents each. 5 candy bars. They're 35 cents each. A box of cheese crackers for 50 cents. 3 packs of sour drops at 20 cents each. And 2 bags of cookies at 75 cents each. Okay, you know, he's got a long day at school. He's got to have all these snacks. Okay? We're not talking about that. Okay, I know exactly where you're going. So, we create what we call a row matrix, which we've talked about, of all of the quantities of things that he bought. So, he bought 4 bags of chips, so we put a 4. 5 candy bars, we put a 5. 1 pack of crackers, it's a 1. 3 drops, 2 cookies. Okay? So, what size is this quantity matrix? How many rows does this matrix have?
5. I'm at row 1.
1 row.
Okay.
How many columns?
5.
0.
5.
Huh?
Oh, yeah. Okay.
1 row. 1, 2, 3, 4, 5 columns. So that's a 1 by 5 matrix.
Oh.
Okay. We then take the prices and we make what we call a column matrix, which we've talked about. So we put how many chips, how much are chips, how much are candy bars, how much are crackers, drops, and cookies. Okay. Notice the order that my row goes in is the same order that my column has to go in. So if I put chips first in my row, the price of chips had to be first in my column. So my column matrix is a what by what? How many rows?
2, 4, 5.
1, 2, 3, 4, 5. So this is a 5 by 1 column. 1, 2, 3, 4, 5 rows, 1 column. Okay, so we've got a 1 by 5, and we're trying to multiply that by a 5 by 1. Well, if I tried to add that, that was a big no-no. But I can multiply. So your rule with multiplying, the amount of columns, so this second number has to match the first number. So this 5, how many columns this one had, has to match how many rows this one has. And as long as that's good, yes, you can multiply.
Okay, I have a question. So what happens if they don't match? What do you do then?
Not possible, just like adding and subtracting.
Okay.
So if adding and subtracting, if they weren't exactly the same, you couldn't do it, not possible. If your columns and rows don't match, not possible. Okay? Good question. Your resulting matrix then are your outside dimensions. So when I multiply these, my final answer is going to be a 1 by 1 matrix. So you should end up with 1 number. 1 row, 1 column, 1 number. So my final answer is a 1 by 1. Question, so. All right. So what happens here and why we end up with a 1 by 1 matrix? Let me go back and erase this for a minute so you can see everything. Yeah. What happens is the quantity of this has to pair up with the price of it. So we bought 4 items for 30 cents. So we would take 4 times 30 cents. Then we bought 5 items for 35 cents. So plus 5 items for 35 cents. We bought 1 item for 50 cents. So 1 times 50 cents. We bought 3 items, each for 20 cents. And we bought 2 items, 75 cents a piece.
So you just enter that in the calculator?
You would enter that into the calculator.
Interesting.
What do you think this is going to tell us when we get an answer?
I don't know.
The total of what? Total amount of money that he spent when he went to the store and bought all these items. That's what you're calculating. Well, most of you are sitting here thinking, well, hey, I could have done this without matrices. Yeah, you could have. Okay. A row times a column is super easy. And most of you have done this several times, just never with matrices.
It's going to be 555.
Okay. So, Ruben spent $5.55.
That's not cheap.
This is probably like back in the day when, minimum wage was probably like $3 an hour and, you bought a newspaper for a penny.
I think it's still $4.
I wonder if it was that time.
Why? As minimum wage goes up, the price of everything goes up. So it balances out. Although these gas prices can keep dropping. I'm enjoying that.
Right.
Whew. $2.09. My friend lives in Ohio. She's like, I just got gas for $1.83 a gallon. I was like, oh my God. They're not always going to give you the matrices. So we're going to have to create them. So it says Ruben's friend Terry is going to go along with him to the store. Terry's buying a bag of chips for 25 cents, 2 candy bars at 45 cents, 2 packs of gum at 30 cents, and a medium drink for 75 cents. So we need to figure first the quantity. I need a quantity matrix. How much of each thing did Terry buy?
1, 2, 2, 1.
So 1, 2, 2, 1. He bought 1 bag of chips, 2 candy bars, 2 packs of gum, and a drink.
I have a question. Why is this necessary? Or we could just do what we did the last time.
Bless you.
Because this is what they tell me I have to teach.
But it's not
It's
necessary.
going to be 2.5.
Thank you for that, but it's not necessary.
It is necessary.
I don't care.
Okay.
Give me this, I'll take
I need to be able to multiply this by how much each one of these items costs. So again, the order that you put the quantity in is the order that you've got to put the price in.
25.
Okay, so 25 cents,
45.
45 cents,
Church.
30 cents,
City.
and 75 cents. So again, when we multiply, the 1 goes with the 0.25. So 1 times 0.25. The 2 for 45 cents. The 2 for 30 cents a piece. The 1 for 75 cents. And Devin already said he spends a whole whopping $2.50. Jonathan, trust me when I say this. When we get to multi-dimension times multi-dimension, you're going to want to use a matrix.
Oh, okay.
You said 250.
250. Am I allowed to say 50 here?
I do have another question though. What kind of job would you use this for?
What kind of a job would you use this for?
Mm-hmm.
Math.
Cashier?
Word. Cashier.
I mean, you wouldn't use matrices, but that's basically what you're doing is you're totaling out a price. You're a cash register. Ding, 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 ding. That's what you're doing. Okay, Okay? Mr. Dunn. Mr. Dunn has $10,000 in a 12-month CD at 7.3% annual yield. He put $17,000 in the credit union at 6.5% and $12,000 in bonds at 7.5%. If you're putting money in, what are you trying to do?
Save.
Save. You're trying to get money. You're trying to make it grow. So we have to be careful. What will the value of his investments be after 1 year? So they want to know if they put this amount of money in at these different rates, how much money is he going to have at the end? Well, we could sit here and do the whole this times this times this times this with the big old freaking things we learned in the last chapter. But it says, let's write a row matrix that shows the current value of each investment. So how much money did he put in the first account?
10,000.
10 grand. How much did he put in the second account?
17.
How much money did he put in the last account?
12.
Okay, so there's A. Write a row matrix that shows the current value of each investment. Write a column matrix that shows the yield of each investment. This is where we must be careful. 7.3% annual yield. We are gaining money. I need to change this to a decimal before I can use it. Remember, we don't use percents when we're multiplying. So, what does 7.3% annual yield look like as a decimal?
0.075 or 7.3.
Okay, 0.073. We're missing something. Remember, we're trying to grow our money. Right now, we're losing money with what you told me. We're trying to grow, which means it has to be over what? If I buy an item, what percent is that item? A whole item.
100%.
100%. We're trying to go over. So don't forget, it has to be more. Don't forget that one in the front. What you write if you point 0.073 is you're decreasing your money. You want it to grow, so you want it to be over 1. So that's why that 1 has to go in the front. Remember when we sat there and we said 20% interest or 20% growth, and you had to sit there and do 100 plus 20, gave me 120, and then that turns into 1.2 because it had to be over 100. That's what you're doing here. That doesn't go away. We're not decreasing, we're increasing. We're trying to gain money. So you would technically add that to 100 first. But if you just change it to a decimal and put the 1 in front, you're safe. Okay. The second investment is 6.5%.
1.065.
1.065. And the last one, 7.5%. So
Is it-
one,
I have a question.
yes.
Is the answer 41,785?
So what?
41,785.
I got 35. Is it 85?
Alright.
I could have put something in wrong. 10,000 times that. 17,000 times. Oh, that's why. You
So, I guess-
mixed your percentages up.
Oh, because I
65
did
should have
this
been here.
and this.
Yeah.
I see.
It has to be in the right order.
So it's 35
Yes.
instead of 85.
So what this does is it takes 10,000 times its 17,000 times its annual yield and 12,000 times its annual yield. By the end of it, he's walking away with $41,735. Yeah.
That's crazy.
Can I get a lot? Oh, we got homework now.
Okay, give me a second. Let me get through this next section and let's talk about the practice, and then I will let you guys roll with it. You only have one problem.
Is it one of those problems with the letters?
You know it is.
So we're gonna do case number 2.
Okay. So, case number 2. Look what's changed. We've made this a tad bit more difficult. We're now doing a row times a multi-dimensional. This is why I said you're going to want your calculators for this. Because when you do this, your row has to multiply by each one of these columns. Okay? So, think about it. This row matrix, 5 and 3, is a what by what? What's this first matrix?
1 by 1.
1 by 2.
1 by 2.
Okay.
Take a look at your second matrix. This is a what?
2 by 3.
3 by 3.
2
2 by 3.
by 3. So 2 and 2 match. So that tells me I can multiply. My final answer then is going to be a 1 by 3 matrix.
Okay.
So I'm going to have 1 row and 3
So
columns.
basically, you just cancel out the checks.
Okay.
The ones that's the same?
Okay.
So you're going to get one answer that is this row times this column. You're going to get your middle answer, which is this row times this column, and then this row times this column. As the matrices get bigger, it's more and more involved. Okay, so if you would actually multiply these through, my answer key, you get this for an answer. $67.32, $72.82, $72.55.
Oh.
Yeah. Okay. Take a look at number 1 at the bottom of your page. It says, write an interpretation of AT12.
Okay. So what's
Okay.
that?
AT means I've taken this times this. So what number is in spot row 1, column 2?
I'm just gonna get the back.
Okay. Which one of these numbers is in row 1, column 2 for your answer? Row 1, column 2.
72.82.
Oh, I was looking at the
72.82.
Yep.
What does that mean?
$72.82.
For what? What's that represent?
A&T
An item.
or AT.
For what?
AT&T, Mr. Phone bill.
Take a look. Take a look up
For
here.
Tony's
And what
Pizza.
each Tony's Pizza, we're in the second column. So we're talking about Tony's Pizza.
Uh-huh.
What else are we talking about?
It's salad.
What did we buy at Tony's Pizza?
Salad. No.
Pizza. What do you mean?
Salad.
For how much?
Pizzas and salad.
5
Which is-
of them.
Oh,
We
shoot.
bought 5 pizzas at
and
Tony's
and 3 salads.
and 3 salads. Each pizza costs $11.96. Each salad costs $4.34. That's why we spent $72.82.
Oh.
We bought 5 pizzas at Tony's for $11.96, and we bought 3 salads at Tony's for $4.34.
Wow.
They may just give you something like this and say, "Tell me why. Tell me why this has happened."
Tony reasonable prices.
So the second number represents the amount of 5 pizzas and 3 salads at Tony's. The first one would represent the amount of pizzas and salads at
What you said, the first?
Vinny's.
Vinny's. And your last one would be these Sal's.
It sound
Okay,
like
so
mob
you
boss
have to be
things.
able to interpret what you're actually doing. Okay,
Miss Smith, why do they all sound like mob bosses?
mob bosses.
Don't they sound like names you hear on The Godfather?
Yes. So, yeah. All right. So, what I want you guys to do right now, while I step out in the hallway for 1 second, if I give you these dimensions, tell me, can I multiply them? Yes or no? And if I can, what are the dimensions of my answer?
I mean,
What?
I don't understand it.
I'm confused.
Okay. What?
Studio single.
Is Miss Woodard staying today?
Oh, Miss Porter.
Oh, you mentioned like what's the finishing?
I think she has detention with the.
I think it is.
Okay, so take a look at A. I've got a 1 by 4 and a 4 by 2. Can I multiply these?
Yes.
Yes. Remember,
1 times 2.
the second number has to match the first number. So this is a yes. I can do that. My answer then are the two outside numbers. So my final answer would be a 1
So if it's
by 2.
sorry, if it's a no,
Then
no.
you can't do dimensions because there's no answer.
Okay, good.
Okay. So B, I've got a 1 by 3 and a 2 by 3.
Yes.
No.
Wouldn't work.
Because it's a 3 and a 2.
Does 3 match 2?
Yes to Gianni.
No, I really. Okay. Oh shoot. Okay, I got you.
You got it? It just clicked.
Good.
What about a 1 by 5 and a 5 by 4?
Yeah.
Yes. What's my final answer going to look like?
1 by 4.
1 by 4. And what about a 1 by 2 and a 4 by 2?
No.
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 See, I get it now.
All right, what's for homework?
He says, okay, what's fine? All right. So what I want you to do, nope,
So easy.
not that one.
This one?
2 and 3 for homework.
I want you to find this one.
What is that?
It should say at the top of the page, matrix multiplication practice. Okay. Because I want you to practice inputting matrices into your calculator and using your calculator, this is a calculator active activity. What I want you to do is input A, B, C to your calculator. And then complete 2A, 2B, 2C, and 2D, just like we did for adding and subtracting. So if you see AB, that means A times B. BA is B times A. BC and CB. Okay. If you end up with an error where it says mismatched dimensions, that means that something went wrong. So if you end up with mismatched dimensions, that means you're trying to multiply something like this. Okay? Which can't happen because the 2 and the 3 don't match.
Okay, I do have a question.
So if you do end up with an error, it's because your dimensions don't match for them to do it.
So is it this one? Or
Yes.
one? Okay. Because if
Why does on the board it say
end
2,
doesn't-
but on the paper it says 1?
Yeah.
Huh?
Because she just put A. It's probably.
See,
She probably took
on the
one out.
board it says 2, but right here it says 1.
Oh, that's because these are from the old notes.
Okay.
That would explain it.